Even when you feel low, you can still go. Even when you feel slow, you can still go. Even when there's no hope, you can still go. I never answer to no, man, I still go. Go, 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 yo, go, go.
Fixed and variable costs in process plant design. As future chemical engineers, understanding these financial concepts is critical to designing efficient, economically viable industrial processes. Whether you're sizing a reactor, optimizing a distillation column, or evaluating the feasibility of a new plant, balancing fixed and variable costs will shape your decisions. Let's explore how these costs apply directly to the chemical industry, with examples from refinery operations, polymer production, and more. Fixed costs are expenses that remain constant regardless of production volume. In chemical plants, these often stem from capital investments and long-term commitments. Examples of fixed cost: equipment costs. A distillation column, reactor vessel, or heat exchanger purchased for 5 million ringgit represents a fixed cost. Whether the plant operates at 50% or 100% capacity, the cost of the equipment remains unchanged. Plant infrastructure or building, mortgage payments for a biodiesel production facility, or leasing fees for a petrochemical storage terminal. Salaries, fixed wages for plant managers, safety officers, or lab technicians. Depreciation, gradual value reduction of a 10 million ringgit catalytic cracking unit over its 20-year lifespan. Imagine designing an ammonia production plant. The Haber process requires high-pressure reactors and compressors, a significant fixed cost. Even if market demand drops and production halts, the plant must still cover loan payments on that equipment. Characteristic of fixed cost. Firstly, fixed costs are predictable, making them easier to budget for during the plant design. For example, a polymer plant's annual 2 million ringgit property tax is a fixed expense that engineers must account for in feasibility studies. In process engineering, high fixed costs raise the break-even point, the production volume required to cover all expenses. Consider a methanol synthesis plant with 50 million ringgit in fixed costs: reactors, pipelines, control systems. To break even, the plant must produce enough methanol to generate 50 million ringgit after covering variable costs like natural gas feedstock. Variable costs fluctuate with production volume. In chemical plants, these are often tied to raw materials, utilities, and consumables. Examples of variable costs. Number 1, the cost of raw materials: ethylene for polyethylene production, crude oil for refineries, or sulfuric acid for fertilizer plants. Energy or utilities: steam for distillation towers, electricity for pumps, or cooling water for exothermic reactors. Catalysts, Josh consumables: platinum and catalytic reformers or activated carbon filters in wastewater treatment. Waste disposal: costs for treating acidic effluent from a nitric acid plant, which scales with production. Imagine a biodiesel plant uses methanol and vegetable oil as feedstocks. If production doubles from 10,000 to 20,000 liters per day, the cost of methanol, a variable expense, doubles. Similarly, energy consumption for trans-esterification reactors rises proportionally. Variable costs are directly tied to throughput. For instance, in a chlorine-alkali plant, producing 100 tons of chlorine daily requires 100 tons of salt, sodium chloride, and specific kilowatt-hours of electricity. Doubling output to 200 tons per day doubles salt and energy costs. Therefore, the operational decisions in plant design includes feedstock negotiations. A vinyl acetate monomer plant might secure bulk discounts on acetic acid to reduce variable costs. Energy efficiency: installing heat exchangers to recover waste heat lowers utility costs per unit. Scale-up challenges: variable costs don't always scale linearly. For example, pumping 10,000 liters per hour of fluid may require disproportionately more power than 5,000 liters per hour due to friction losses. So, what is the relationship between fixed cost versus variable cost? Well, it affects the overall cost structure. Together, fixed and variable costs make up a company's total cost structure. Fixed costs provide stability but can be burdensome if production levels are low. Variable costs allow flexibility but can strain cash flow if production rises sharply without corresponding sales. Example: in manufacturing, a factory with high fixed costs, e.g. rent, machinery, will require high production levels to spread those costs, while variable costs, e.g. raw materials, labor, adjust to match production levels. Balancing fixed and variable costs. Companies often aim to optimize their cost structure by finding a balance between fixed and variable costs. Reducing variable costs or controlling fixed costs can improve profitability.